Do you believe aliens exist? Your answer would be one of three categories: the neutral, the believer, or the dismissive. The neutral do not argue for or against the idea of aliens being real. Their central argument is, we've never seen aliens, but we can't prove they don't exist either. The believer stance promotes the idea of aliens existing as a fact. Their central argument is, it is impossible for Earth to be the only planet with life. The universe is far too big for that same rare chance to not also happen elsewhere. Now, the dismissive stance is convoluted without a central argument to it. Most justifications are by a hunch, by religious views, or the idea that aliens are just drawn from fiction. But there is one rare argument of the dismissive stance that can compete with the other capable arguments, which is, the complexity of DNA makes it near impossible to say alien life must exist, despite the size of the universe. We will be shedding light on this dismissive stance argument in order to see how it holds up and what exactly it stands for. But didn't NASA find bacteria on Mars? Not exactly. The headlines were a bit misleading, but what they actually found was an asteroid from Mars. They believed it contained fossils from ancient bacteria that used to live on Mars. However, the study was inconclusive, and they said it was not absolute proof. But let's see for ourselves just how likely life could form on its own. So first, what makes a life form? There are 8 characteristics of life that need to be met in order to earn this title: organization, reproduction, metabolism, homeostasis, heredity, response to stimuli, growth, and adaptation. By these standards, bacteria are alive, but viruses, being much smaller, are not alive. So what allows for bacteria, the world's smallest living organisms, to live? They need at least a proper body that is able to interact with a proper DNA strand, and the code the DNA contains needs to be correct in order to sustain itself and reproduce. So to find out how likely a proper life form can form, we need to find the chance of a proper body forming times the chance of it forming with an intact DNA strand, times the chance that the code gives the cell all the proper information needed to uphold the 8 characteristics of life. However, since the code DNA contains is so complex, we'll focus solely on the probability of the code forming correctly. Because if it's impossible for a functional code to be likely, then we don't even need to consult the other factors to reach a conclusion. This will also help with the ideas of theoretical life. Aliens may not run on traditional DNA or cell patterns, but could still meet the 8 requirements. However, in order to meet several of these requirements, alien life would have to follow some sort of built-in biological code. This is another reason why we'll be focusing solely on the code that is built into the organism and nothing more. So, to understand the complex code DNA contains, let's get a better understanding of how DNA operates. DNA is made of a long chain of A's, G's, C's, and T's, which form the code. DNA, essentially, is a long line of these letters that form the programming that living organisms need to sustain themselves and reproduce. There is room for forgiveness, but the organism will not meet the 8 standards of life if too much of its DNA is improperly coded. The code is precise, and not just any randomly formed code will work. So how short can a DNA strand be in order to sustain a living organism? Meet the Candidatus Tremblaya princeps. It is a bacterium with only 138,927 base pairs. That's how many A's, G's, C's, and T's are in its DNA. It may seem like a lot, But this is as small DNA can be for a cellular organism. As a result, the T. princeps can only survive through symbiotic relationships because of how small its DNA is. Its survival is achieved by living inside mealybugs, and also by having another bacterium living inside itself. That being the Candidatus morinella endobia, which has 538,294 base pairs. So how likely can a DNA this long form correctly by random chance? Let's study the mathematics. If your phone has 10 possible digits and is 4 digits long, there are 10,000 different combinations. This is because the number of possible digits to the power of how many digits long equals the total amount of different combinations. This means a random attempt would have a 1 in 10,000 chance of unlocking your phone. So how likely is it for a random chance to give the correct DNA code for a T. princeps? That would be the amount of possible digits to the power of how many digits long. This gives us a near immeasurable amount of different combinations, making the likelihood of a random chance succeeding near impossible. For reference, the amount of grains of sand in the world is 7.5 times 10 to the 18th power. The amount of drops in the oceans is 2.664 times 10 to the 25th power. The estimated amount of atoms in the observable universe is 10 to the 82nd power. But the amount of different combinations we concluded on is exponentially larger. So it begs the question, can any amount of circumstances make the chances of alien life likely? Let's find out. Let's say that there is a bacteria machine on every planet in the universe. They each make bacteria with the same DNA length as the T. princeps. Every machine is in sync with each other, not as individual efforts, but one large cooperative effort to create one bacterium with the correct DNA pattern. So that's the probability of life divided by our estimated numbers of 8 trillion planets times 2 trillion galaxies in the observable universe. However, it barely reduces our probability, even with 1 trillion already being a massive number. 1,000,000 seconds is about 12 days. 1 billion seconds is about 31 years. But 1 trillion seconds is about 31,709 years long. So 1 trillion is no small number. So let's keep cutting this probability by trillions. We could say that there are 1 trillion DNA codes that could be successful, that the universe has 1 trillion more planets than estimated, that the machines have made a new DNA pattern for every nanosecond, of every second, of every minute, of every hour, of every day, of every year, for 1 trillion years. Maybe times another trillion, multiplied by another trillion, another. The probability is still impossibly high. What if we multiplied the size of the universe by the amount of atoms in the observable universe? That would be 10 to the 82nd power. Still, it barely reduces it. What if the universe was multiplied again by this number? And again, and again, and again. No matter what we do, no matter what circumstances we give, the chance that life formed somewhere out there is by no means likely or guaranteed. So in addition to how we've never discovered aliens, and to how large the universe is, we now also know just what kind of complexity life forms are made of. This shows how unlikely it is for something this complex to form on its own. Although the universe is massive, that alone does not prove aliens exist.